So in this video, we are going to look at a different kind of formal proof for this particular circle theorem we've been talking about. And once again, we are looking at the proof by contradiction. Okay, so we're doing this using congruent triangles. So what we've done, similar to the last video, I've supposed the OP is not perpendicular to ST. So on ST, I've taken a point E. So I've drawn in a new point and I've drawn in our point X. Similar to the one from the previous video, I've drawn in this point X on there and I've drawn in another point E, and I've written this such that XE equals to PX. So I've drawn this in a way, I've supposed that there are these other 2 points and I've constructed them in a way that XE is equal to XP. I've made these equidistant to each other. And I've joined OE with this dotted line. So in these two triangles, so in triangle OPX and triangle OXE, so OEX, OXP, angle OXP equals angle OXE. And remember, this is similar to my previous video where I've drawn X so that it is perpendicular, so that OX is perpendicular to ST. So I'm going to say it's 90 degrees by construction. Because remember, like we've done in the last video, we're assuming there is some point X on the line such that OX is perpendicular to ST. S is down the bottom here. So if that's perpendicular, that means that OXP has to be 90 degrees and OXE has to be 90 degrees because they're angles on a straight line. So they must be the same. We've also said by the same construction that I've done, PX equals to EX by construction. Okay. Now, we also know that OX is common in these two triangles. Since we know these three things now, we can say, now just bear with me, this is a long proof. We can say that OPX is congruent to OEX. This is by side, angle, side. And since these two are congruent, we can say that we know about congruent triangles that corresponding sides of congruent triangles are equal, okay? So we've talked about this side, that this angle is the same, and that these sides are the same. So because they're congruent triangles, obviously just looking at it, we can tell they're not. But remember, this is the assumption. We're following all the logical steps, and then we are going to find a contradiction. Now, since these are congruent, then OP must be the same as OE, since they're corresponding sides in congruent triangles. So let me write that in. So we're going to say, therefore, OP equals OE. And we're going to say corresponding sides in congruent triangles are equal. Okay, now, as OP is the radius, then because these sides are the same, as OP is on the radius, E must lie on the circle. We can clearly see it doesn't lie on the circle. Otherwise, it should have the same length. Here is where our contradiction comes in, okay? Now, what we're going to say is, therefore, so because P lies on the radius, E doesn't lie on the, because P lies on the circumference, but E doesn't, circumference, but E doesn't, they are not the same. Therefore, a contradiction exists. Now remember, if a contradiction exists, then this kind of false claim we made that suppose that there is a point X so that OX is perpendicular to ST, this is wrong. So a contradiction exists. So because a contradiction exists, we can say, therefore, the assumption that OP is not perpendicular to ST is false. Since this is false, therefore, angle OPT equals 90 degrees and OP is perpendicular to ST. Can feel like a bit of an essay when you're writing kind of trickier proofs like this, but this is getting you to think in terms of a way that we're taking some false narrative, we're running with it using the same logical processes as we've done here. We've proved congruence, assuming this. We've gone through, we've done everything, and then using that congruence, we've said that, okay, then OP must equal to OE because they're corresponding sides in congruent triangles. But by the picture, if they are to be the same, E must lie on the radius. That's the only way that OE will be the same as OP.